In this video, we're going to look at the perimeter of circular shapes, and we're just going to concentrate mostly on the theory, and in the next video we'll look at some examples. So first and foremost, the perimeter. When we talk about the concept of perimeter, it's the distance around a shape. So as an example, if we just had a triangle and the sides were 1, 2 and 3, the perimeter would be 6 units. You add up all these sides together. Okay, so it's like you're traveling around an object. Okay, so think of the perimeter of a park. That's the outside or the boundary of the park. The perimeter around a circle is called its circumference. Okay, so please underline these words. Very important when we talk about circumference. It's just perimeter, but it applies to a circle. Okay, a couple of other terms that we need to understand is that the radius. Okay, I know hopefully we've seen that word before. The radius is the distance from the center of the circle to any point on the circumference. Okay, so a good way to demonstrate radius is if you were to stand on the spot, for example, and you had your arm out and you spun around. Okay, your fingertips would mark out a circle. Okay, and the radius then would be basically your arm length. And the diameter, so that's another term that's actually related to the radius. The diameter is the line passing through the center of the circle from opposite points on the circumference. Okay, circle's not exactly circular. I mean, I did my best to try to draw that freehand, but basically the radius is this line here marked with the R. Okay, and the D is the length of the diameter. And notice that the diameter goes from one end of the circle, or from one side directly to the other side. Okay, so we can see that the radius is actually half the diameter. Okay, so the radius R is half the diameter D. Okay, so radius is, I guess if you wanted a formula, radius is equal to half times diameter. Now that becomes important later on when we start looking at the formulas around the perimeter and area, for example, concerning circles. So the circumference around a circle is given by the formula C equals 2 times pi times R. Sometimes, well, a lot of the times we don't show the multiplication symbols. We would write it as C is equal to 2 pi R. Okay, you might have heard of the song Twinkle Twinkle Little Star, circumference equals 2 pi R. So there's the 2 pi R. It just means 2 times pi times R. Another formula that comes up, and I have seen this, around, circumference equals pi times D, or pi D. My favoured formula, personally, I prefer just to use the 1 and just always work in terms of the radius. But that doesn't necessarily make it any more correct than if you wanted to use, for example, pi times the diameter. And the reason for that is because when you're using the formula for the area of a circle, that's pi r squared. Okay, so nice just to work with the one variable instead of having to think, oh, do I need radius or do I need diameter? Okay, so if a question gives you the diameter, personally, I just halve it and then just work with r. Always just work with the radius. Okay, but like I said, whatever works for you, you just do whatever you think, whatever you're used to. If that's giving you the right answers and you're understanding the ideas, just keep going that way. Lastly, the arc length of a sector, okay, is given by the formula L equals theta over 360 degrees times 2 pi r. So L is this bit of the circle. So the circle kind of goes all the way around. So when you're talking about a sort of a kind of like a slice, a slice of pizza or a slice of cake, or that kind of a shape, if it was a circular shape to begin with, a sector kind of sort of has that kind of a shape, characteristic shape, and we're only talking about just the curved part. Okay, so I guess just before I end the video, if you wanted the perimeter of a sector, what would you do? Okay, in fact, I might just write it here in red. Perimeter of this sector is equal to, you've got L. Okay, so L you have to work out using theta on 360 times 2 pi r, plus you've got an R there. Okay, so if you're going, let's say there was a park or some sort of oval or something, in this shape, you've got R, you've got this arc length there, and then you've got to come back to your starting point. Okay, so there'll be in fact two lots of these R's. So L plus 2R will then give you the perimeter of the sector. Okay, next video we'll look at some actual concrete examples and including composite shapes as well, where, for example, you might have a rectangle and a semicircle, for example, and then you wanted the perimeter of that shape.